All right. Today we're going to talk about graphing rational functions. We solved rational equations, right? Remember the difference between an equation and a function. With a function it equals y instead of a numerical value. So we got an x and a y. With an equation we just have a single variable. And rational basically means a fraction. So to be a rational equation or a rational function, we have to have a variable in a denominator. Just because our equation has a 1/2 in it doesn't make it a rational equation or function, right? It's that variable in the denominator that makes it a rational function. Okay, so since we have variables in denominators, we know denominators cannot equal 0. So we're going to have some issues with this graph. It may have one or more breaks in it, so its graph will be discontinuous. Since the denominator cannot equal 0, the graph will never intersect a vertical line that makes the denominator 0. This line is called the vertical asymptote, right? A value where the graph moves closer and closer to a horizontal line is called a horizontal asymptote. So asymptotes are just these values of the graph that it gets closer and closer and closer to. Okay? Now before, remember when we were graphing our functions, we said the first thing was we determined the shape. If we had a quadratic function we're graphing, we knew it was going to be a parabola. We just have to figure out if it's skinny or fat or upside down or over here, right? And with the other polynomial functions, right, we knew their end behavior, and then all we had to do was figure out what's going on in the middle. For rational functions, these asymptotes are going to tell us the shape. Okay, so to determine asymptotes, if it's vertical, if we're looking for the vertical asymptote, set the denominator equal to 0. Then the line x equals a is a vertical asymptote. And remember, this is just like when we were talking about the axis of symmetry. It's actually a line. So it doesn't make sense to say the vertical asymptote is 3, right? The vertical asymptote is the line x equals 3. To tell if we have a horizontal asymptote, you simply compare the degree of the numerator with the degree of the denominator. Okay? If the numerator is a smaller degree than the denominator, you automatically have a horizontal asymptote at the equation y equals 0. Okay? So right through that x-axis. If the numerator and the denominator have the same degree, then your horizontal asymptote is an equation in this form where this a sub n is the leading coefficient of your numerator, b sub n leading coefficient of your denominator. If the degree of the numerator is bigger than the degree of the denominator, there's not a horizontal asymptote. But if it's bigger by exactly 1, then we've got something called an oblique asymptote. It's also called a slanted asymptote because instead of being horizontal or vertical, the asymptote's going to be slanted. Okay, so to find it, we're going to actually divide, right, the numerator by the denominator, and we'll disregard the remainder, and then we'll have an equation for a line. And we'll look at that. I think we're going to practice that right now, as a matter of fact. Well, next slide, I guess. Okay, here's the steps for graphing a rational function. So if you want to pause this and get these steps down, with your other lists that hopefully you have somewhere. First, always simplify the rational function if possible. That goes without saying. Fractions always need to be simplified, but it's really important here because it might change our graph. So we need to simplify it if possible. We're going to find the vertical asymptotes by setting the denominator equal 0, and then the horizontal or oblique asymptotes by comparing the degrees. Now these asymptotes are really important. This is over half of our graph, finding the asymptotes, right? It tells us the shape of our graph. By the way, we can have numerous vertical asymptotes, right? We can have many, many of them, and none, but we could have many of them. Okay, so you can have as many. If you had a quadratic in that denominator, you're going to have 2 vertical asymptotes. If you have a 5th degree polynomial in that denominator, you could have 5 vertical asymptotes. But you can only, after your vertical asymptotes, you can only have one other one, either one horizontal or one oblique. Okay, only one of these. Okay, after we find our asymptotes, we find the x-intercepts by letting the numerator be 0. Find the y-intercepts by plugging in f as 0. See if the graph intersects that horizontal asymptote. It cannot cross a vertical asymptote. Your graph cannot cross a vertical asymptote, but it can cross a horizontal or oblique asymptote. Okay, find extra points as needed. Okay, after we get our basic points, which always consist of x and y intercepts, right? Then we need a few extra points depending on the kind of equation, and then draw the graph by connecting those points. Okay, so now it's asking us to find the asymptotes. We're not graphing these yet. Let's just find the equations of any vertical, horizontal, or oblique asymptotes. To find the vertical asymptotes, all we do is see what values make the denominator 0. Because denominators cannot be 0. You cannot divide by 0, right? So this one's already factored for us, so that's nice. That means x equals 1/2 is a vertical asymptote, and x equals -3 is a vertical asymptote. Okay, after we find the vertical asymptote, we look for horizontal or oblique by comparing the degree of the numerator and the denominator. Well, to see what degree this is, I need to multiply this out. So I'm going to have, when I multiply this out, 2x squared. Right, if I were going to multiply this out, I'd have 2x squared. And then I'd have plus 6x minus x minus 3. But here's what I'm interested in, just the degree, right, which is the biggest exponent. And the degree up here is a 1. So if the degree of the numerator is smaller than the degree of the denominator, you have a horizontal asymptote at y equals 0. Okay, so for this one, to find the vertical asymptote, we set the denominator equal to 0. So we're going to let x equals 3. So this is our vertical asymptote. To find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. Since they're the same, then our horizontal asymptote is y equals, and we just take these leading coefficients from the numerator and the denominator, so 2 over 1, or 2. Okay? To find the vertical asymptote, simply set the denominator equal to 0. So x equals 2. Okay, then to find the other asymptote, if there is one, compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is bigger than the degree of the denominator, there's not a horizontal one. So there's not a horizontal one, but if it's bigger by 1, there's an oblique asymptote. And to find it, I simply do the division. And we can use synthetic division to do that. Don't forget there's a missing term here. So here's 1x squared plus 0x plus 1. We're going to divide by 2, right? My k value. Bring the 1 down. 2 times 1 is 2. Add them together. And then, I don't care what the remainder is. We're going to discard the remainder. But this equation will be y equals, okay, and remember, if this started out being a quadratic, this is a linear, so x plus 2. So this line now, y equals x plus 2, is our oblique asymptote. So that's how we find the asymptotes. And that's the most important thing of graphing these functions. Half of the graph involves knowing what your asymptotes are. Okay, so let's try it. All right, so first of all, this won't simplify any, so I'm going to find my asymptotes. Let the denominator equal 0 to find my vertical asymptote. And then compare, to find my horizontal, compare the degree of the numerator, which I don't even have a variable up there, to the degree of the denominator. If the degree of the numerator is larger than the degree of the denominator, I automatically have an asymptote at y equals 0. So there's my two asymptotes. I'm going to go ahead and draw those in. All right, so x equals -1 is a vertical line like this. Make it dotted. It's not an actual part of your graph, but it's a great feature. Y equals 0 is a horizontal line. Now, my graph will follow these lines as each piece goes off to infinity. So I already know a whole lot about my graph. I know it's either going to be a curve like this or this. It can't be both, because if it was both, it wouldn't be a function. Think about the vertical line test. So it's either going to go like this or this on this side of my vertical asymptote, and then this and this on the other side. So all I need are a few points to tell me where my graph lays. Points that I definitely want to have are my x and y intercepts. X intercepts are when y equals 0, right? So if I let this function equal 0, think about this a minute. If this is a fraction, what makes a fraction equal 0? A fraction is only equal 0 when the numerator is 0, right? The denominator cannot be 0. So when the numerator is 0, hey, this numerator cannot ever be 0. It's 2. There's not a variable up there. It's 2. So there is no x-intercept. So to find my y-intercept, I let x be 0. So I plug in f of 0 equals 2 over 0 plus 1, or 2. That means I have the point 0, 2. Okay, so right here. I have a point right here. So now I know it's up here, right? And also, my next step in a typical graph would be see if it crosses this asymptote, because what if it comes under it and follows it off the end? Or does it stay above it? I don't know. But since we already determined there's not an x-intercept, meaning there's not a point on here, that's where my x-intercept would be, I know that it doesn't cross it. So now all I need to know is, well, how quickly does it get to this line? So let's just plug in 1, 2, 3, maybe f of 3. Here's where we get our extra points. So 2 over 3 plus 1 is 4. So that's 1/2. So I have a point at 3, 1/2. That's enough. I know what happens, because it's going to follow this, and it's going to follow this closer and closer and closer, but never actually crossing either one of them. Now all I need to know is over here, is it a curve here or here? So let's plug in f of -2, just somewhere in that interval. So 2 over -2 plus 1 is -1. So now I have the point, -2, -1, all right? And now I've got a very good approximation of what's happening. If I needed to be closer, a really close approximation, just do extra points. Do this point, right? Maybe do this point here and see how close, how quickly it gets over there. Okay, you might want to do a point in between here. But this is a very good graph for this function. Okay, let's try it again. First of all, I'm going to factor this to see if this will simplify. My first step is always, and I need this factored anyhow to set it equal to 0 to find my vertical asymptotes. But always see if your function will simplify first. We'll see one eventually that does, and then we'll know why that's important. So here I need two numbers that multiply to give -3, but add to give 5. So I don't have a shortcut, so I can just rewrite, not -3, but -6, -3 times 2. So I just rewrite my problem Two numbers that multiply to give -6 and add to give +5. That should be +6 and -1, right? -3. So now I can factor these things by grouping. Factor out a 2x, and that leaves x plus 3. Factor out a -1, and that leaves x plus 3. So we have x plus 1 in the numerator, and 2x minus 1 times x plus 3 in the denominator. All right, so it doesn't simplify. So check that first. Since it doesn't simplify, my next step is to find my asymptotes. Vertical asymptotes are whatever make the denominator equal 0, right? So x equals 1/2. So that would mean the point 0, 1/2. Oh, no. We're looking for asymptotes, so this is an actual line. So it is x equals 1/2 and x equals -3. So I've got two vertical asymptotes this time. To find the horizontal asymptote, compare the degree of the numerator with the degree of the denominator. Because the degree of the numerator is smaller than the degree of the denominator, that tells me I have an asymptote at y equals 0. All right, now these are lines, not points. They're not an actual part of my graph, but they're an important feature, so I'm just going to draw them in as dotted. X equals 1/2, that's a vertical line right here. X equals -3, and then y equals 0. Okay, so once again, my graph will follow these lines. So over here, the only thing it can do is make a little curve like this, following close, getting closer and closer to this one, and then closer and closer to that one, or down here. Same over here, either like this or like this. Now in the middle, it can either follow it and then turn and follow it, do that up here, or it could cross, right? Remember, it can cross horizontal or oblique ones, but not vertical. So let's get a few points and see if we can tell what's happening. The first points we always want to get on any graph are x and y intercepts. X intercepts is when we let y equal 0. For a fraction to equal 0, it's when the denominator equals 0, right? So if x plus 1 is 0, then x equals -1. Now this is a point, right? This is our intercept. It's a point. So if x is -1, y is 0. It's this point right here, -1, 0. Hey, that also tells me that it is touching or crossing this one, so it saved me that step again. Now let's find our y-intercepts. Y-intercepts is when we let x be 0. So if I plugged in 0, let me change this for parts of the graph. The asymptotes are not part of the graph, so just for emphasis, keep it in a different color. All right, so if I plugged in 0 for x, I'd have 0 plus 1 is 1, and then 0, 0, minus 3. So -1/3. So I have a point 0, -1/3. 0, -1/3. Okay, now my next step would be to see if it ever crosses this horizontal asymptote, but we've already been told that it does. So once again, I can forego that step and just go to, now I need a few more points. Let's get one over here, just so I can, because I still don't know if this goes like this or if it comes up and then goes like this. So if I plug in f of -2, I get -2 plus 1 is -1. Okay, if I put a -2 in here, -2 squared is 4 times 2 is 8. 5 times negative 2 is negative 10. So 8 minus 10, negative 2 minus 5. Let's double check that math, plugging in a negative 2. Okay, 4 times 2 is 8 minus 10, negative 2 minus 3. Okay, so this is the point, negative 2, 1/5. So negative 2, 1/5. It's just barely over here. So I know now, don't draw too much more than what you know, but I know it's doing this. Now it's going to get closer and closer to this line forever, and this one forever, but it can never cross it. Okay, so let's find a point out here and see if it's up here or down here. That's all I need to know. 1, 2, 3, 4. So let's do f of negative 4. Negative 4 plus 1 is negative 3. Okay, negative 4 squared is 16 times 2, 32, minus 20. So that's 12 minus 3. 12 minus 3 is 9. So this is negative 1/3. So I have the point, negative 4, negative 1/3. All right, so I know it looks like that. Okay. And one more point, maybe two. Let's do f of 1. 1 plus 1 is 2. 2 times 1 is 2 plus 5, 7 minus 3 is 4. So that's 1/2. That gives me the point. Whatever, you know what I'm doing. That should be an arrow. Okay, it gives me the point 1/2. So there's 1 and 1/2. It's already really close to this, so I really don't even need to get a point out here. Now, if I'd have gotten a point up here, maybe I'd want to get a point, out here to see how quickly it gets, but it's already very close to that. So close, so quickly, let's check our math, right? So we're doing 1. 1 plus 1 is 2. Okay, so 2 plus 5, 7 minus 3, 4. Yeah, looks good. Alrighty, let's try it again. Okay, this thing won't simplify. Okay, so I need my asymptotes. What makes the denominator 0 is if x equaled 3. If I compare the degree of the numerator to the degree of the denominator, since they're the same, then my horizontal asymptote is that y equals 2 over 1, or 2, right? Y equals 2 over 1. Okay, so let's draw in our asymptotes. That's half of our graph, remember? Tells us everything about the shape. All I need then is a few points to nail it down. Okay, so x is 3. And y is 2. So now, other than the location of these asymptotes, it's going to be just like that first one. It's either here or here, or here or here. Okay, the points that we definitely want are intercepts. So x-intercepts is when y equals 0. For a fraction to equal 0, it's when the numerator equals 0. Right? So what would make this numerator equal 0 is if x equaled negative 1/2. Now this is a point. This is an intercept. So it's the point negative 1/2, 0. Okay. And then for my y-intercept, it's when x is 0. So you plug in a 0. Right? So f of 0 equals 0 plus 1 is 1. And 0 minus 3 is negative 3. So this is the point 0, negative 1/3. Let's see what we have when we plot these points. Negative 1/2, 0. and 0, negative 1/3. All right, so over here, I know what's happening. It looks like this. Okay, I just need to find out what's happening up here and here. And I need to know, is this going to cross this line and then follow it from the top, or is it going to just stay under it? So this one, I didn't get that information in the previous parts of whether it's going to cross that line or not. So to find out, we just take our function and set it equal to the equation of that line, 2. Right? Is it ever going to equal 2 so that there's a point on that horizontal asymptote? All right, so to solve this equation, I'm going to multiply both sides by x minus 3. That'll cancel this one. So that gives me 2x plus 1 equals 2x minus 6. If we subtract 2x from both sides, I have 1 equals negative 6. And no, it doesn't. No, it doesn't. Okay, so that means it doesn't cross that asymptote. If I would have gotten x equals negative 6, I know, oh, when x is negative 6, it's on that line. And I'd have a point there. This is saying, no, it doesn't cross that asymptote. Okay, so then I just need a couple other points. I know everything I need to know about this. Let's do f of negative 4. Do it up here. F of negative 4 is negative 8 plus 1, negative 7, over negative 4 minus 3, negative 7. So it's 1. Remember, that's a point. That's the point. Negative 4, 1. So negative 4, 1. All right. So I know. Let's do, just to see where it's at f of 1. Right? Let's just do f of 1. Just to see, because this is a long way over. Okay. So 2 plus 1 is 3. 1 minus 3 is negative 2. Okay. So at 1, we're at negative 1.5. So negative 1.5, we're about right here. So, okay. We're going to imagine that went through that point. Now I just need to know what's happening over here. Let's do 1, 2, 3, 4 to get me this side of that asymptote. So let's plug in f of 4. Okay, so 8 plus 1 is 9. Over 4 minus 3 is 1. That's 9. So this is the point, 4, 9. Okay, so we're way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 4, 5, 6, 7, 8, 9. We have a point up here. And I'm just going to do like that. Okay, there's our graph. Very good approximation of that graph. Okay, let's see what else can happen with these things. All right, let's factor this thing up to see if it simplifies. I can factor 3 out of the numerator. The denominator is a perfect square trinomial, so I know how it factors. I need this all factored up anyhow for other steps. So checking to see if it'll simplify in the beginning. Doesn't really add anything extra. All right, two numbers that multiply to give negative 2, add to give negative 1. That would be negative 2 and positive 1. Right, so it doesn't simplify, but I've got it all factored up for me. Okay, so now finding the vertical asymptotes, it's when is the denominator equals 0? Well, x equals negative 4. Horizontal asymptotes, I compared the degree of the numerator with the degree of the denominator. Since they're the same degree, then y equals 3 over 1 is going to be my horizontal asymptote. So let's draw those in, and this time since x equals 4 is my vertical asymptote, let's go by 2's on this one. Let's just go by 2's on both of them, just to see. Okay, so x equals 4 would be right here. And y equals 3 would be right here. Okay, just like the others. The graph's either going to be right here, or right here, right here. I just need a few points. Points I need to start with are my x-intercepts. All right, so x-intercepts is when y is 0. What makes a fraction 0 is when the numerator is 0. So this time we've got two x-intercepts. We've got an x-intercept when x is 2, that is the point, 2, 0, and when x is -1. -1, we said, -1. Okay, so -1, 0, right? From right here. Y-intercept means you plug in a 0. So you'd have 0, 0, -6, and then 0, 0, plus 16. So that's -3/8. So this is the point. 0, -3/8. All right, let's plot them. 2, 0, -1, 0. See what's happening here. And 0, -3/8. Okay. That looks a little strange, so I'm going to double check my math. Okay. So we're good with the factoring. All right, so x is 2 and -1. And then, oh, -4 is my, let's see if we can do this. Okay, what makes the denominator 0? Oh, I drew it at -4. I just didn't write -4. Okay, but yeah, I drew it at -4. Okay, so let's see if these points, +2, -1, and then -6/16. Okay, let's see what's happening. Our next step is then, does this actually cross this asymptote right here? So I take my function, 3x squared minus 3x minus 6 over x squared plus 8x plus 16 and set it equal to that asymptote. Set it equal to 3. And then solve this equation. Okay. So if I multiply both sides by x squared plus 8x plus 16, it will allow me to cancel it on this side, so that I would have 3x squared minus 3x minus 6 equal 3x squared plus 24x plus 48. Okay, if I subtract 3x squared from both sides, that goes away. Okay, Let's move my 24x over. So minus 24x from both sides gives me minus 27x minus 6 equals 48. Let's add 6 to both sides. Minus 27x minus 27x equals 54. Divide by negative 27, so x equals negative 2. Okay, at x equals negative 2, now the graph makes sense to me. At x equals negative 2, it's going to be on top of this asymptote. So what happens is now it's following this, but it crosses it, dips down, and then comes back up and follows it like this. So I know everything I need to know about that. That's why it's really important. We need to know if it crosses an asymptote. All right. Just to be doubly sure and get as good a graph as we can, let's even do oh, these are going by 2, so 2, 4, 6, 8. Let's do f of 8. F of 8 and see where it is. And it's going to be easier to do it where it's factored, right? So we'd have 3 times 8 minus 2 is 6 times 8 plus 1 is 9 all over 8 plus 4 is 12 times 12. 12 times 12. Now we could do that math, or we could simplify it a little bit and let that be a 2. And then also this 12 and that 3. So what do we have there? 9 eighths, or 1 and 1/8. 8, 1 and 1/8. So at 8, then there's 1 and 1/8. So it's getting closer and closer and closer. Okay, now I just need to know what's happening over here. So let's do, and I know it doesn't cross that again because I've already found out the values that it crosses it. So 2, 4, 6. Let's do f of 6. Okay, so that would be 3 times 6 minus 2 is 4. 6 plus 1 is 7. Okay, 6 plus 4, so this is 10 times 10. Okay, so I could, any that have common factors, I could do this. So that's going to be 6 times 7, 42 50ths. Yeah, I could have done that 2 again. So 42 50ths, 21 25ths. So at 6, you're just barely 21 25ths, you're nearly at 1. Okay, I have another question now because it's got to go down like this. So I've missed a sign somewhere. Let's see. I wonder if that's okay. 6 minus 2. Oh, because I'm doing negative 6. Duh. See how important your signs are? Negative 6. So also knowing these features of graphs like that, you know, helps us catch some mistakes. Like I was like, it can't cross that. I already have all of my intercepts, and that's not one. So I need to plug in a negative 6. Okay, so that's still going to be 3, but now it's going to be negative 6 minus 2. Okay, negative 6 plus 1. And then in the denominator, it's going to be negative 6 plus 4 and negative 6 plus 4. So 4 negatives is going to be a positive. Okay, so I can take this 4 out of here. So 3 times 2 is 6 times 5, positive 30. This is the point 630. So we got a point way up here. 2, 4, 6, 8, 10, way up here. All right. Just same steps over and over. And knowing a few things about these asymptotes and what they mean helps us. Like at first I was like, this is odd, but oh, it makes sense if it comes down, because when it crosses, it'll usually make a little dip and then go back and follow. Okay, and it was odd down here. No, it can't cross that. I've already got all my points on that. I knew I made a mistake. All right, let's try it again. Sorry, my phone's ringing off somewhere. I don't know where it is to shut it up, so it's across the room. Y'all just have to listen to it for a minute. Sorry. Okay, so this won't factor in the real numbers, so this won't simplify any. So our first step then is just to find our asymptotes. Vertical asymptotes are where the denominator equals 0. So we've got x equals 2. Okay, then I'm going to compare the degree of the numerator and the degree of the denominator. The degree of the numerator is larger than the degree of the denominator, so that means there's not a horizontal one. But if it's bigger by only 1, there's an oblique one. To find out what the oblique one is, we're going to do synthetic division. We're actually going to do this division. We're going to do x squared plus 1 divided by x minus 2. And we can do that with synthetic division. All right, so 1x squared plus 0x, there's a missing term there, so don't forget your placeholder, and I'm going to divide by 2. So 2 times 1, add them together, 2 times 2, and I really don't care what that is because I'm going to ignore it. That means this equation right here, which is linear now, because the original equation was a square, we divided, so it's going to be 1 less, so it's x plus 2. I've got an oblique asymptote this time. Okay. So now, I can draw my asymptotes in at x equals 2. And then, this is the line x plus 2, right? So my y-intercept is 2. Slope is 1. All right, just so we have room up here, I'm going to go back and make this go by 2's again. Maybe we'll just leave it like this and just go off of the page, right? Okay. So now I'm either going to have it my graph like this or this or this or this, right? Same thing. It doesn't change anything except this is slanted instead of horizontal. So I need some points. Okay, so if I'm finding my x-intercepts, x-intercepts is when y equals 0. When a fraction equals 0, it's only the numerator that we're concerned about equaling 0. So if I were to solve this equation, they're complex numbers. Okay, so that tells me there are no real x-intercepts. I can't plot them on here. I can't plot real numbers on here, so it will not cross this axis. My graph will not ever cross this axis, right? There are no x-intercepts. Y-intercepts is when you let x be 0. So you would get 0 plus 1, 0 minus 2, negative 1/2. So you've got a point at 0, negative 1/2. Negative 1/2. So really I already know what happens because it can't cross that. It's just going to go like this, right? It's going to go like this. Now I can get a couple extra points, and let's do that. Let's do 1, 2, let's do f of -3 just to see exactly how quickly it falls. Okay, -3 squared, that's 9 plus 1 is 10. -3 minus 2 is -5. So that's -2. So that's the point, -3, -2. So here we are. It's right here. All right. So I know it's like this. And if we want to do f of 1, 1 plus 1 is 2. 1 minus 2 is -1. So it's also at -2. So 1, -2. Okay, and then I need one more point. Okay, because I know it's either going to just be voom or voom. Okay, and actually I know it's going to be up here because it can't cross that, right? We already said it can't cross that, so it's just going to be up here. My question is just where? 1, 2, 3. So f of 3 is 9 plus 1 is 10. 3 minus 2 is 1. So that's the point. 3, 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got a point up here. Okay, so if your asymptote is oblique or slanted, there's nothing different. Except how you get that asymptote, of course. All right, let's do one more. Okay, on this one, notice this thing will simplify because that factors to x plus 2, x minus 2, and you've got an x minus 2 in the denominator. So those divide out, and look what that means. That means really all we're doing is graphing a linear equation. Remember, it doesn't have to have any asymptotes. But, so it's the same graph as this with one exception. There can be no value when x equals 2, right? So, but it's not an asymptote this time. The graph isn't going to follow some line. It just jumps over that value. So all it does is it just makes a hole in the graph. So I know when x is 2, if I plugged a 2 in here, 4, so at 2, 4, there's a hole in the graph. And that's all. If the denominator cancels out, we still have to account for the fact that, hey, x cannot be 2. But it doesn't mean there's an asymptote. So now if I wanted to plot this, again, my y-intercept is 2, my slope is 1. So I've got points like this. I just got to remember to put that hole in my graph. So don't forget to see if it'll simplify first. Okay, that should not only do it for this section, but that does it for all of chapter 3. So next time we'll start chapter 4. Okay, let me know if you need any help. I know these last couple of sections on this graphing is, intense. So please, let me know what you need. All right, thanks. See you next time.